Hello everyone. So here we have a nice question from quadratic equations. The question is a quadratic whose roots are alpha beta, another quadratic whose roots are gamma delta, and there is some relation given in alpha beta gamma delta, and they are asking about the coefficients whether they are in APGP. So let's start. So one thing is given here that A, B, C, D, E all are positive. So if the coefficients of a quadratic are positive, then the roots will be negative because no positive value will make the quadratic 0 again. So here both the roots of both the quadratics have to be negative. That means alpha, beta, gamma, delta all are negative. Fine. Next thing is given is this relation. So if I open this modulus, what I am getting is alpha plus gamma equal to plus minus beta plus delta. So considering plus sign, I am getting alpha plus gamma equal to beta plus delta. Considering minus sign, I am getting alpha plus gamma equal to minus beta minus delta. So we can write this as alpha minus beta plus gamma minus delta equal to 0, or alpha plus beta plus gamma plus delta equal to 0. So as we have seen here, all the values alpha, beta, gamma, delta are negative. So adding all negative can never be 0. That's why this will not be the correct case. Now this case is fine. Alpha minus beta and plus gamma minus delta can be 0. Already they have given these conditions that alpha is greater than equal to beta and gamma is greater than equal to delta. That means alpha minus beta is non-negative and gamma minus delta is also non-negative. So adding two non-negative, if I add these two, what I am getting is alpha minus beta plus gamma minus delta. So definitely it will be 0 or greater than 0. But adding these two can only be positive if we are not considering alpha equal to beta or gamma equal to delta. But here in the first equation, what I am getting is alpha minus beta plus gamma minus delta equal to 0. So that is only and only possible when alpha minus beta is 0 and gamma minus delta is 0. So if alpha minus beta is 0, that means alpha equal to beta, and gamma minus delta equal to 0 means gamma equal to delta. So the first equation will be satisfied only when alpha is equal to beta and gamma is equal to delta. Now if alpha is equal to beta, that means the quadratic first has the equal roots, and equal roots means the discriminant is 0 of this quadratic. Ax square plus bx plus c equal to 0 has discriminant equal to 0. Discriminant 0 means b square minus 4ac equal to 0. Similarly, the second quadratic given cx square plus dx plus e. Here also we are getting gamma equal to delta means equal roots means discriminant equal to 0. So d square minus 4ce equal to 0. So these are the two relations we are getting in A, B, C, D, E. Now coming to options, the first option they are saying A, B, C, D, E are in GP. So if A, B, C, D, E are in GP, so B square is equal to AC or C square equal to BD and D square equal to C, like that we can form some relations. But these relations we can't obtain from these two obtained conditions. So option A will never be the correct one. Coming to option B, we have C square equal to AB. That also is not possible to get from the given things. Gone. C is, they are saying in AP. AP means will be 2B equal to A plus C, and like that 2C equal to, we can write B plus D and so on. But this also will never be satisfying the obtained two conditions. So here A, B, C, all three are incorrect. Option D is the correct answer in this question. So this was a nice question from quadratic. Thank you everyone.